Welcome to my channel. Today we see the relationship between the molar and equivalent conductance. Molar conductance is represented by the letter, it is lambda m. Equal conductance is represented by the symbol, it is lambda e. You know the definition for molar and equal conductance. Let me say what is the definition for molar and equal conductance. I take a electrolytic solution. Suppose I take here sulfuric acid solution. Here in first case, you see I take how much amount of sulfuric acid is present in this solution. That is 1 mole of sulfuric acid. H2SO4 is present. What is called 1 mole? It is a molecular weight, that is called gram molecular weight of sulfuric acid. The gram molecular weight of sulfuric acid is 98 gram. This much amount is present. Now I ask, what is the conductance of this solution which contains 1 mole of electrolyte? It is an electrolyte. That conductance is named as it is molar conductance. Second case I take, it is molar conductance, that is called lambda m. Second case. Now in that case, instead of 1 mole, I take here 1 gram equivalent weight of H2SO4. What is the 1 gram equivalent weight of H2SO4? That comes the value, it is 49, it is gram. Suppose I ask here how much amount of sulfuric acid is there. I say 49 gram. Or I say how much amount of electrolyte is there. It is a solution which contains 1 gram equivalent weight of electrolyte. So the conductance of this solution is called equivalent conductance. Here it is lambda e. You all know that expression for lambda m and lambda e. It is known to you, lambda m is equal to, what is that? It is kappa, specific conductance, into V. What is called V? V is volume which contains 1 mole of electrolyte dissolved in it. That instead of this here V, we substitute 1000 by here molar conductance, molarity m. This is. Here what is the unit for this? The unit is known to you, so no need to write the unit. Then what is the definition for expression for lambda e? Kappa into here volume which contains 1 gram equivalent weight of electrolyte. So it is kappa into 1000 by it is here. That's all. These are the definitions for molar and equivalent conductance, as well as the expression for molar and equivalent conductance. Using these here two equations, one is this and two. Using these two equations, I am going to derive the relationship between molar and equivalent conductance. The last relationship alone I can write. What is the relationship? It is lambda m is equal to n into lambda, it is e. It is lambda e. Lambda m is equal to n into lambda. What is this n? You want to know. Suppose I take electrolyte. For electrolyte, I take 3 different types of electrolytes. There, one is called electrolyte salt, acid, and bases. This n is related to salt, acid, base. Suppose I take here how to find out the equivalent rate of salt. Here equivalent rate, you all know equivalent rate of salt. Weight of any salt is equal to, what is that? Salt which is not acting as oxidizing or reducing agent. For such type of salt here, the equivalent weight is equal to molecular mass divided by that equal either total number of positive or negative charges. This is the equivalent weight of any salt. Suppose if I come to the equivalent weight of acid, you all know that formula is equal to, it is acid. What is the equivalent weight? It is molar mass by instead of total number of positive or negative charge, we can go for this basicity. Then you come to here bases. What is the equivalent weight of base? For that, it is molar or molecular mass by acidity. This acidity is called N, this basicity is called N, this total number of either positive or negative charge is called here N. Then if the salt is here, we can go for if the salt is oxidizing agent, if the salt is oxidizing agent, go for the formula for equivalent weight. It is molecular mass by here. If it is an oxidizing agent, during the reaction it will undergo reduction. Reduction means gain of electron. This gain of electron is called N. If it is a reducing agent, go for it is equivalent weight is equal to, it is molecular mass by it is number of electrons lost. Reducing agents are the substances which will undergo oxidation, so number of electrons lost. This is called N. Generally I take what is the relationship between the delta M and delta E. It is multiplied this N value. Suppose I take different electrolyte. For an example, I take here calcium chloride, it is a salt. Sodium chloride, it is a salt. Calcium phosphate, it is a salt. Twice. Then aluminum sulfate, Al2SO4 thrice. I take here sulfuric acid, HNO3, nitric acid. For this here I am going to derive the relationship between lambda m and lambda e. Lambda m is equal to n into lambda e. For this, how to find out the n value for this? Here it is a salt, it takes 2 plus and each Cl carries here 1 minus, so it is 2 minus. It is Na plus minus, it is Ca 2 plus, PO4 3 minus, it is Al here 3 plus, it is 2 minus. Here H2SO4, each H carries here 1 plus, it is 2 minus. Here H plus NO3 minus. This is for this. What is the n value? Total number of positive or negative charges. Total number of positive 2. Here total number of positive negative 1. Total number of positive here 3 into 2 6 or 3 into 6 6. Here 3 into 2 6 or 3 into 2 6. Here how many positive charges means 1 H plus H carries 1 plus, so 2 H plus, it is 2 plus. Here 2 plus 2 minus, so 2. Here 1. I can go for one more. Here I can go for, suppose I can go for here a base like this NaOH, and I take phosphorus acid H3PO3. Here for this, what is the n value? It's a base. A base means acidity. Acidity means here number of OH minus ion released by a base. When it is dissolved in water, number of OH minus ion released is 1. That is n value. Here how many H is there? 3 hydrogens are there in a molecule. When you dissolve this in water, only it releases only 2 H plus ion. So here n value takes here 2. Now I write how these are each electrolyte for molar and here equal conductance are related. So molar for this here molar conductance is equal to n value 2 into equal conductance. Here for this molar conductance is equal to 1 into equal conductance. So molar conductance is the same. Here it is molar conductance is equal to 6 times of equal conductance. Here molar conductance is equal to 6 times of equal conductance. Here molar conductance is equal to here 2 times of equal conductance. Here molar conductance is equal to how many times? 1 time of equivalent conductance. Here molar conductance is equal to, what is that? 1 time of equivalent conductance. Here molar conductance is equal to here 2 times of equivalent conductance. Thanks for watching my video.